Greetings everyone, I would like to present our research titled Visual Question Answering for Mona's Tourism Object Using Deep Learning by myself, Ahmad Hasan Siregar, and my supervisor Dina Cahyati from Faculty of Computer Science, University of Indonesia. I also would like to thank Ministry of Research and Technology of Republic Indonesia that has funded this research. First, the outline of this presentation is introduction of the problem and related research. Next is Mona's VQA dataset. Next is our proposed methods and the result and its analysis. The last is conclusion and future work recommendation. So, what is visual question answering? Visual question answering is a task with input a pair of image and visual question in natural language. The output is answering the question in natural language as well. For example, on the right side, we can see an image of Monas, National Monument of Indonesia, with the question, what activity are visitors doing right now? The correct answer is strolling, for example. So, as we know that the image and the question is on a different media. The image is on image space, while the questions is in text space, or text media. So it's interesting that visual question answering involves multimodal machine learning so that the image and the question can interact with each other. For example, a model should understand the region of interest in the image based on the question asked. Second motivation is that there's currently no VQA dataset that has question in Bahasa Indonesia. So, in this research, we use Monas, an Indonesian national monument, as the topic of the dataset we compiled. Therefore, we name it as Monas VQA dataset. A related research is that Anto et al. 2015 published a popular VQA dataset that contains 200,000 images, 760,000 questions, and 10 million possible answers. The dataset is used to host an open challenge for researchers. On the right side, we can see past year's performance. Each year, we can see a significant performance increase. But still, on the last year's, 2019, we can see that the best performance is 75%, and we can improve, and we can see that this accuracy still can be improved furthermore. The proposed baseline methods that Anto research use multi-class classification approach. The approach uses choose K 1000. So the top K most frequent answer are chosen as the output classes. So the proposed methods on our research using the same approach with Monas VQA dataset as the benchmark. We use multi-class classification approach. So the criteria on our dataset, we have two criteria. The first is question criteria. That is a single sentence. A question should be a single sentence, consists of some words terminated with question mark, written in Bahasa Indonesia. The third, the question should be answerable with the given information from the image and does not require any pre-knowledge or information outside from the image. For example, where is the nearest bathroom from here is not a valid question because the model should know where are all the location of the bathroom. The image doesn't give that information. The fourth criteria, the question should ask something that requires some information from the image. For example, what is the name of the topmost part of Monas is not a valid question because the answer of it is always Cawan Monas. The image criteria should contain Monas object, either whole or partial. The image can be real or abstract. And for the resolution and aspect, we don't give any limitation. So the dataset collection will be, so there are 7 questions. There will be 7 categories for each questions. So for each image, there will be 7 questions from each category. 2, the image collection is sourced from our internal research team. And then 3, For each image, one of the two annotators creates a question and answer the question as well for all categories. We can see on the right side that we collected 384 images, with 216 images are erased because either it's a duplicate or blurry, and 2,447 questions. We can see right here there are seven categories with each distribution. And we can see here there are this is a question length distribution. We can see the question length ranging from 3 words to 13 words. And this is the top 10 most frequent answers. There is yes or no for binary category, white is a color category, and etc. This is some examples. We can see on the right side, the first two images contains real monas. With this one contains real monas object, whole monas object. This one contains real and partial monas object, while this one contains an abstract monas object. Here are some examples. For example, object categories. The question is, what is the name of the part of monas shown in the photo? Some probable answers would be cawan monas or tugu monas. For example, spatial categories, where is monas located in the photo? Some probable answers are middle or right side. So, after the dataset is collected, we apply some post-processing steps. There are two steps. Those are answer aggregation and low-frequency answers filter. The answer aggregation will merge different written form answers that have the same meaning. For example, orange color in Bahasa Indonesia is oranye, can be written with the same meaning but different form. There is jingga, it's a synonym, or non-standard way, oran, or a typo s, jeans. So the algorithm would calculate edit distance of all the possible pairs, and then we will check manually to determine if they have the same meaning. For the low frequency answers filters, we will erase some answers that have two low frequencies, as well as its corresponding question as well. For example, right here, we can see there are 4 SIMs. This is only use 95% of data to 80% of data. We choose data 90% to balance between data completion and the reduced distinct answers. So the final size after post-processing, we have 384 images with a reduced 2,226 questions and 56 distinct answers. So here are the first proposed methods of our research. This model contains 3 big components. The first is the image embedding parts, the question embedding parts, and the final is the dense layers parts. So the image embedding use ResNet CNN architecture with layers are frozen and then some global average pooling, and then we normalize it and apply transformation layers, that is dense layers, with dropout probability. The image embedding, we use 2 BOW, bag of words. The first bag of words will encode top 300 words of questions from the whole question dataset. And then the second BOW is a topic encoder. It will encode the top 10 words of the first 2 words. So for example, some example is, what is the color of monas right now? So what is the first words and is the second words of the questions. It is important because the topic of the question will determine the possible answers. So the model will have bigger distinction power using the topic encoder. So both BOW will be concatenate into 1 by 320 factors, and then it will be forwarded into the dense layers. First, it will be concatenate between the image embedding and the question embedding output. And then we will have two dense layers with its dropout probability. And the last, we have softmax distribution to get the answers. This method is trained using categorical cross entropy loss, Adamax optimizer, 0.001 learning rate, 32 batch size, 100 epochs, and all dense layers are using 10H activation. This is the second method, is ResNet plus BERT. The image embedding part is more or less the same with different dimension, vector dimension, and the question embedding use BERT instead of BOW. We have BERT and then we apply global pooling and normalization and transform using dense layers into 1 by 1024 factor representation of the question. So because the output of the image embedding and the question embedding is the same, we can apply multiply operation and we get 1 by 1024 mixed representation of the question and the sentence. And finally, we get the answer distribution using softmax. This method is trained using the same configuration with the difference are 128 batch size and 250 epochs. The ResNet and BERT layers are frozen. So this is the last or the third methods. The image embedding is the same, but we use bidirectional long short-term memories instead of BERT. But first we embed each words using fast text and we forward into bidirectional long short-term memories, and the output we use is the cell memories, and the output of each memories concatenate into 1 by 13 words, the 13 words because the longest question is has 13 words, and then we apply some global pooling and we concatenate all of the output. We get 1 by 2048, and then we transform into 1 by 1024 representation, and we apply the same operation, multiply. And then the interesting part here is we have topic encoder, first two words as well, and when we concatenate with the output of the mixed representation, and we get the same using softmax. This method trained using 32 batch size and 150 epochs. So the results are, we have the first method with 60% accuracy, the second method 66% accuracy, and the best performing methods we have 68.39%. And then it's interesting to analyze the influence of ResNet, the influence of image and the question to the performance accuracy. So we experiment on a single input model. For example, this one, we only use the ResNet part or the image input part. We get 11.21 accuracy, and we only use the question input. We only use BOW. We have 57%, and fast text only we have 55.61%. The table above shows that question has a higher distinction power compared to image. Also, because question has that big influence, we try to dig deeper into question category. We can see on this table that the blue part is the accuracy of each category. Meanwhile, the red line is the number of distinct answers that is normalized. We can see that binary and time has the lowest distinct answers and top two accuracy. And then the next is activity, attribute, and colors has more or less the same distinct answers. And then the interesting part is even the object has higher distinct answers compared to spatial. It has higher accuracy compared to spatial accuracy. This shows that there are some inherent difficult category to solve. Some possibilities is the CNN architecture or the ResNet doesn't encode the location of objects, so the spatial category that answers the location of the image or object is not really that good performance. Some visualization we have, for example, here the question is, how is the weather in Monash right now? The answer or the prediction of model is cloudy, while the labels is cloudy, so this is true. For example, this one, we can see here is Monash, while on the right side is a street lamp. The question is, where is the street lamp located in the photo? The model predict the answer is back, meanwhile the labels is right, so this is a wrong prediction. So the conclusion, we have created a Monash VQA dataset consists of 384 images, 2,226 questions with 56 distinct answers. Future work should add more manpower to increase raw data numbers and use validators to cross-validate answers and category. We have proposed some methods. With the best performing methods, we call as ResNet plus FastText plus bidirectional long short-term memories plus BOW with accuracy of 68.39%. Also, we found that question has higher influence on accuracy compared with the image input, as well as the number of distinct answers has some impact on accuracy, as well as some categories contain some difficulties as well. Future work could improve on unexplored methods possibilities. For example, a training monolingual BERT on Bahasa Indonesia use different CNN architecture or different NLP techniques. Thank you. This is the end of presentation.